To all the watchers out there, thanks for tuning in. I am Yvan from UbiOps, and today I have this pleasure of speaking with Wilmar. Now, I'm always excited to learn from AI and machine learning practitioners, but today I am particularly excited as Wilmar and his team are working on some really cutting-edge technology. So enough about me, let's jump in. Wilmar, would you like to tell us a little bit about yourself?
Yeah, I'm Wilmar. I'm part of the innovation team at Ridder for almost 2 years now. And I have a background in image recognition, and that started with image analysis on satellite images, and we've moved to greenhouses now. And that's my main focus in the innovation team at Ridder.
Yeah. Right. So you started out in computer vision. How did you end up specifically in, horticulture and agriculture technology?
Well, I studied in Wageningen University, and I think a lot of people that end up in greenhouse technology studied there in the Netherlands. So also the image analysis on satellite images was image analysis on bigger plantations, like involving plants or trees, stuff like that. And that's. I just wanted to combine technology with the green world, basically. So that's how I ended up in horticulture also.
That's great. That's great. So this way you can scratch that data science itch, but then also kind of contribute back to the planet.
Yeah, exactly. And the nice thing is that you now are a software developer, and so I also worked at a project with banks, for example, where I also was a software developer. But now I'm a software developer that actually can also go to the growers, see the object that it's all about. So it could be as simple as a tomato plant, and just really interact with it. And that's what I really like. Yeah.
That's really great. And so at Ridder, you are a product innovator. So what does that mean? What do you do? What does your day-to-day look like?
So I'm part of the innovation team. What we do there is we try to keep Ridder innovative, and keep in line with the latest trends of horticulture. So what I'm doing there is focused on computer vision. Ridder thought, okay, we see that there's a trend emerging in computer vision in the horticulture, so we also need to keep or get someone with knowledge of this in our team. And my day-to-day work is basically developing new algorithms, talking to customers, validating new concepts, and talking to possible partners that help me with this. Yeah.
Oh, that's fascinating. And it seems like you must be doing a very good job, because Ridder was nominated for a concept award at the Green Tech conference recently in the Netherlands. Would you like to share a bit more about that?
The main goal of Ridder is to provide innovative solutions for greenhouses and integrate possible solutions just to help the growers and optimize their yields. Mm-hmm. And at the Green Tech conference, we basically participated in the Innovation Award of a category concept, which means that it's a promising product for the sector, but not yet a finished product yet. And yeah, we basically presented our latest innovation there, which was called Ridder CropView AI.
Right. So yeah, can you talk a little bit more about CropView AI? Like, this was the technology that your team presented at the conference, right?
Yeah, exactly. So actually, the reason why we started with this was that growers in their greenhouses now are measuring a lot of stuff. And most of this stuff is around climate. So you can imagine you can measure the temperature of the greenhouse or the humidity, but there's not a lot of smart sensors that actually measure things on the plant. There are some, but not enough.
Yeah.
And this is what it's all about. So what growers now do is every week is they go to their plants, they perform manual crop registration measurements, so measuring the plant growth or the thickness of the stem, for example. And they use that, or we use that, for example, to predict yield. And what we wanted to do is we wanted to automate that with computer vision. So we created a camera that looks at the plants and does the same thing, but now it's objective. You can take pictures every hour, I don't know, every minute, so you can increase the temporal scale, and in that way you have just more valuable data. And that's what we presented there as a concept. Yeah.
Great. So far we've mentioned growers, plants, horticulture, green tech. So we're talking about a specific domain here or industry that Ritter operates in. And that's the domain of horticulture or agriculture technology. So Wilmar, what is horticulture technology or HortiTech, as some people like to call it?
Yeah, so we are, what we're basically trying to do is we want to move greenhouses, which are already really smart. We want to move them to the next level. And we do that by improving their efficiency, their yield, or maybe they're decreasing their environmental impact. And in generally, we do this with digital innovation, like again, computer vision or big data analysis. Or we do that with new hardware, like robots, new sensors, etc. And greenhouses are constantly evolving. They are smart already, but still there is a lot of ongoing research and development, which just keeps on focusing on getting better quality, getting better yield, and all that stuff. So that's what HortiTech is all about. Yeah.
Right. Yeah. So we're talking about technological advancements, and indeed, AI and machine learning are really playing a role there. So how does the HortiTech domain specifically benefit from AI, machine learning, and well, eventually MLOps as well?
Yeah. So my domain is image recognition, and in image recognition. So when I started, it was a bit more basic. That's about 7 years ago. And there were already some deep learning models, but there were not really defined standards. But now, if you look at image recognition, deep learning is used everywhere. So think, of course, of the most used example, self-driving cars or facial recognition on your own mobile phone. And what happens there is that objects are detected in their context, and they are analyzed, and sometimes there's even a decision made after that analysis. And this is exactly the same in greenhouses. So we need to be able to detect really complex patterns, plants, or even tomato stems or little flowers on plants. And we need to use that to predict, for example, the stem diameter, or even go a step further and predict the yield for the coming 2 weeks. Now, for this part, we need AI or deep learning, and because it's just a superior technique. And then we need MLOps to actually get valuable information from those detections. The grower doesn't really want to know where did you detect a plant. He wants to know what is the stem diameter and how did the stem diameter evolve the last few weeks, and how do you think that it's going to evolve the coming weeks? So that last bit is also important.
Yeah, it's all about that value at the end of the day. And that's such a great answer. But I would like to just add a quick definition of MLOps in case anyone watching is new to the concept. So MLOps stands for machine learning operations. It's what we do at UbiOps, and it basically encompasses all the processes required to successfully take an AI or a machine learning model to market. So everything from ensuring availability and reliability of your models to managing computing resources and optimizing performance. Some teams try to solve their MLOps challenges by externally sourcing functionalities from various tools or cloud providers, or others try to build everything in-house and invest in expensive hardware and resources. In most cases, it ends up being a combination of both, which can get super messy. UbiOps basically streamlines the entire experience to go through one single control plane while maintaining compatibility with cloud setups, in-house setups, anything and everything in between. Anyway, enough about us. Back to you, Wilmar. I'd like to know your perspective on like the latest AI trends that are going on in HortiTech.
Yeah, so I've been to the green tech, and I think that's a great place to be if you want to know about the latest AI tech trends in HortiTech. And for image recognition, of course, the main eye catchers are the new autonomous drones or the harvesting robots, which are autonomously driving through the greenhouse, and they can capture images to predict yield or track pests, or also do crop registration like we do. And there are even drones trying to eradicate pests. And Ridder, I already said, harvesting robot Ridder is next to CropView AI, also working on a harvesting robot together with MetaMotion. So there's lots of startups, and lots of ideas. And what we believe in at Ridder is that accessible computer vision is really important for the development of autonomous greenhouses. And this is like the dot on the horizon that we want to go to. And to get there, we just need accessible computer vision, because then we can help growers to get more frequent, more reliable, and also higher quality data of their crop.
Yeah. I think what you said there about accessibility to machine learning, I think that's kind of why UbiOps and Ritter get along so well. I think we have a similar kind of aim there where we're also trying to champion access. We want people to have good accessibility to AI machine learning and not be held back by, maybe specific limitations that individuals may have. So you've spoken about a few kind of or hardware solutions there, like robots and drones. Are there any specific types of computer vision models that you have found specifically useful in what you're doing?
Yeah, so this is going a bit into detail, and I have some models, but of course it's relevant. Like there are relevant models because I want to detect something. It's really dependent on what you want to detect. So what we use most of the time is just object detection models, bounding box detection models, or instance segmentation. And what's more important is that we always use existing frameworks. So we are not developing our own models, but we build on existing libraries like YOLO V8 we use a lot, or Mask RCNN is also a famous one, I think. And the main reason for using these existing frameworks is that these are built by people that are really good at it. And that means that we can focus our attention on basically extracting the valuable information or deducting the valuable information from the output of this model and helping the growers in that way.
Yeah. I think that's a really great way to go about it. I think you're gaining a lot of speed there, aren't you? And actually a lot of accuracy and precision with your models.
Yeah, exactly.
Yeah. Just going to provide a little bit more info for those that are unaware. So YOLO V8 is the latest version of the YOLO object detection algorithm developed by Ultralytics. It can be used to detect like a wide range of object classes out of the box with high accuracy and really, really low latency, meaning it can be used in real time. Whereas Mask RCNN is a two-stage deep learning model for instant segmentation and object detection, which was originally proposed by the Facebook AI research team. Mask RCNN tends to be more accurate than alternatives like Yellow V8, and it generates precise, like pixel level masks, but it has a higher latency due to its two-stage architecture, which makes it not quite suited to real-time detection. Also, it requires pre-training, whereas Yellow V8 doesn't necessarily require that.
Yeah, and I think what's also, if I want to add like 2 lines there, I think what's also interesting for me about YOLO V8, the latest version, is that it does not only do object detection, but it now also does object classification and instant segmentation. And that was new for me, so that might be interesting for people to hear.
Great, great. So I imagine there's different applications that you would use for either of those. Sometimes real-time detection is going to be more required for you, whereas in other cases, you really want to have the maximum possible precision.
Yeah.
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 So, yeah.
I think most of the time we do the latter because growers tend to be they want to be close to the actual measurements. So, and if you, for example, measure crop characteristics, it doesn't make sense to do that real time because it's not that the plant is changing that much in a second, basically. So if you can do it at once every hour, then it's better to have a more accurate model.
Yeah, that makes sense. That makes sense. So with those definitions and introductions to concepts out of the way, I'd actually love to know more about some of the pains that Ritter has faced in regards to MLOps, so machine learning operations.
Yeah, so I think the main challenge is that if you look at the greenhouse, you think, so this is a really stable environment. This is the perfect environment to apply machine learning in, but that's maybe for the entire global environment the case, but not for individual plants. They're moving quite a lot during the day. They point towards the sun a little bit. They're growing, and their tomato crops are lowered about once every week. So that means that they're moving around quite a lot, changing. And the deep learning model needs to deal with that. So it needs to be robust to detect all those changing patterns. And then another thing which happens in greenhouses, of course, quite a lot, is that the light conditions change. There's lots of light, and you also need to deal with that. And I think those are the biggest challenges, which you can partly solve with just giving the model more data, but also partly you need to solve this in the software. I forgot about one occlusion of objects. If you want to measure a stem and there's a stem at a certain spot, and there's just a leaf in front of that, how do you solve that? Those are some of the biggest challenges I think that you will have. Yeah.
Right. And would you say these are more kind of general problems that any HortiTech business would face, or were these kind of specific to what Ritter was facing?
This is really specific on computer vision.
Right.
And I think it also, and if you keep in that subject, I think it is really different on what kind of camera system you have, because we have a static camera system. And of course, then occlusion is a bigger problem than if you have a moving 3D camera system. I think if you have the latter, then tracking the plants will probably be a bigger issue, or like that. Like every system will have different challenges. So I would say there might be a bit specific to Ritter. Yeah.
Right. And so when you had developed your computer vision models and you wanted to deploy those into production, take those to the market, were there any additional challenges that you faced?
So I think one challenge that we faced but quickly solved was that we don't have a large innovation team. And if you want to bring a model to the market, that's quite a hassle. So you need to create your online platform, of course. You need to test out lots of things. You need to train new models. And we started by doing this, so about 1.5 years ago on, this laptop that I'm talking to now. And that's nice if you have a small test data set, but not so nice if you also want to work on the laptop while it's training a model. So basically what happened is we contacted UbiOps, and I think that solved the main challenge for us there. Yeah.
Great. And so what kind of advice would you give to other businesses to kind of get around these challenges or even avoid them altogether?
I think it's really important, and I think Ridder is trying to do that. It's really important that you don't reinvent the wheel all the time, and that's quite a saying that you hear often. But the thing is, people keep doing that quite a lot, and it's actually more expensive, and the final product will just be worse. And if you want to keep up in the current market around the AI, then you need to be fast. And that means that you need to focus on the part where your business is good at. And for us, that's giving growers the best product. So we need to focus on that part and not focus on creating an entire MLOps platform.
Yeah. I think, we definitely align on that. I completely agree. I would actually say that across industries, from HortiTech to even medtech to fintech, there are AI-enabled organizations as well as AI-aspiring startups out there that are facing MLOps challenges every day. And it's actually so interesting to hear about the different ways in which these complexities can manifest themselves. And one thing that essentially always comes up is speed. Everyone wants to be fast. Everyone wants to stay competitive in what is a blindingly fast domain like AI. So with that said, I'd actually like to ask you a few questions about your collaboration with UbiOps. So like, how has UbiOps helped to alleviate Ritter's MLOps challenges?
Yeah, so as you mentioned, speed. Basically, that's the real short answer. We are an innovation team, and if you basically the startup in Ridder, and as a startup, you need to be able to iterate really fast, to validate problems, to throw them away, and to restart a new model. And I think that's we moved from my laptop to now a platform that can run on big GPUs. So I think this we can just try out way more in a shorter period of time now. Yeah.
And what did the sort of UbiOps implementation look like? What was the experience like to start working with UbiOps?
Basically, I'm not sure if it's only Python, but you would know that probably. But if you know how to program in Python, you can automate that using UbiOps. So they have a Python API, and I already wrote my code in Python, so that was quite a perfect fit. And I can talk about our main pipeline. What happens is it basically gets an image from the cloud. It detects the relevant objects. Then it uses those objects to create a new image, does again another detection on those images. And then finally, we in Python, a Python script that's also running on UbiOps, it transforms both of these detections into information for the grower. And this is sent back to our own platform, which is called Hortos. I think that's the main pipeline that we have. And another pipeline that we have is is more basic, and that's basically just training new models using UbiOps. Yeah.
Great. So I'm glad you mentioned Python. You're absolutely right. You can do all these functionalities through straight through Python. You can also do it in R though.
Okay.
So yeah, for some, usually in research or that kind of field, that's becomes a bit more relevant. But I'm very glad to hear that you're actually using our newer training functionality that we released this year. How are you finding it so far?
I must say I didn't change it to the new training functionality yet. So, but I asked for it, so I really need to do it. But I'm training models on UbiOps, but I need to find some time to move it to the new training functionality. So that's my bad, not your bad, because I know I talked about it with some colleagues of yours. And
I mean, I would say it's your bad. If you have a system that's working, I mean, why break it? So how long did it actually take your team to get your models up and running?
You start at UbiOps with like a month sort of trial and getting it up and running, and I think that month was definitely enough. So, as I said, if you know how to Python and your Python code is good enough, then it runs on UbiOps, and you can actually test that offline on your laptop, which works quite well. So it took about a month, but it's still a concept. It's not a finished project, so I won't say it's finished. We're still improving it every week, basically. So.
Right. And has Ritter seen a measurable impact on their AI or machine learning performance and time to market, since we were talking about speed before, since collaborating with UbiOps?
I will not try to talk about the speed improvements too much, but I think one thing which is also important, another thing is that now we can train bigger models than I could train on my laptop, obviously. And that means most of the times that you get more accurate results. I think that's important. And I think another thing is that it is, and I've already developed that it's now way easier to link the output of these models to our online platform, because else I also would have need to develop, I don't know, something in Azure where I'm totally not skilled in, which would have converted the results and uploaded it to our online platform. So I think those are two impacts that are not speed, which we've seen improve. Yeah.
Right. Yeah. We covered speed already. Good
to
cover.
I can keep talking about it, but
yeah. I talk about it a lot, so don't worry. I can cover it for the both of us. So you mentioned a bit kind of like our API functionality there. Are there any particular UbiOps features that have proven especially useful for you and your team?
So I am using this API functionality really a lot. But you mean you're talking about online pipelines and stuff like that, I think?
Yeah, so you mentioned kind of our Python library that we have. But you also touched on pipelines. So are you using that a fair bit?
Yeah, so that's basically where I started with, and the interesting thing there is that for us, I think is that you can upload small pieces of Python code that do something, and that all can run on a different compute. So some parts can run on cheaper CPUs. And some parts, like the detection models, run on the more expensive GPUs. And because we're now still in concept phase, that might not really matter, but you can imagine if you have 10,000 clients, customers that are using that pipeline, then that will make a big difference. So I think that was the most interesting feature of UbiOps.
Great. It's great that you're thinking ahead. For a bit of additional context here, so UbiOps can be used through our web app or through an IDE like Visual Studio Code or Jupyter Notebooks, for example, or even through a terminal. And this is thanks to our extensive API library, which grants data scientists access to most functionalities straight from their preferred interface. Pipelines, on the other hand, one of our most popular features, allows users to chain together multiple deployments and use predefined functions or operators to, for example, introduce conditional logic or manage the flow of data through a pipeline. And as Wilmar said, this can be a great way to delegate computing resources efficiently and actually optimize your costs in the process or deal with high amounts of requests. So we've talked about features that UbiOps does have right now. Are there any features that Ritter would like to see added in the future?
Well, not really. So not on the top of my mind. So what happened at the beginning, which was like January this year, is there were some features, maybe a few small bugs, but then I had a meeting every week where I could notify the UbiOps team about those requests or those bugs, and they would be taken up most of the time fairly quickly. And that's basically still the case. So if I really want a feature to be added, then I can send a request, and then it will be, most of the time it's added or it already exists. So I don't have anything right now. So that's a good thing, I think.
Yeah, I think that pretty much sums it up, really, our approach. I mean, usually there will be some way of doing something, whether it's simple or complicated. But as we learn more from our customers and learn more about what people are doing and how they're actually using our platform, then we can kind of simplify specific tasks into more easy to follow workflows. So yeah, I would actually want to say thank you, Wilmar, for talking with me about some of the challenges your team at Ritter have been facing in training and serving your machine learning models, and how UbiOps was able to help your organization save both time and money. Before I let you go, I'd actually like to shine the light back on Ritter, if I may, and ask what the kind of next couple of years are going to look like for the company.
Of course, we will keep innovating and developing solutions that support growers with their daily and future challenges. And specific for CropView AI, I can say that we plan to run a pilot with multiple customers this year, and we use that pilot to gather more data so that we can improve and validate our existing models. And early next year, then we want to have a more robust prototype and that is able to at least detect 3 different plant characteristics, and that we think that would be sufficient to move from the pilot customers to actually real customers. So those are some big steps the coming 6 months. So that's going to be exciting, I would say.
It sounds like you've got your work cut out for you, Wilmar.
Definitely.
Yeah. Thanks again, Wilmar, for joining me today and for sharing your insights on horticulture technology. I really appreciate you taking the time. It's been an absolute pleasure talking to you.
Thank you, Yvan.
That was an enlightening conversation. At least it was for me. And I'm sure there are a few watchers out there that gained some valuable information today. If that sounds like you, or if you resonated with any of the challenges Wilmar brought up, remember you can always reach out to us for more info or guidance, or check out our website. I would strongly recommend it. We've just updated it. It's looking particularly fresh. Otherwise, this is Yvan from UbiOps. Thanks again for watching. I'll see you next time.